Oh no, what is this? Oh, are you getting any resound? No, na? Okay. Oh, this is troubling me a lot. Oof. Aman sir. Yeah, it's fine now. So I hope you all completed this answer. So everyone, please comment me your answers in this comment box. Okay, let me try it. So a set of EMF 2V and if internal resistance 1.5 ohms is connected between two ends of the wire. Okay, 1 meter long wire. Resistance per unit length is given as, wow, this is resistance per unit length. Okay, no problem. This is something strange thing, right? Yeah, find the value of potential gradient on the wire. So first of all, if a question is given in this way, what you will do? You have to draw a battery. You have to draw a small resistance beside this. Okay, so this is having 2 volts EMF, and what I have to do? Connect a wire. This is of 1 meter long. Okay, okay, chalo. Though the find value of potential gradient, what you have to find? Potential gradient, which you have a just idea. Potential gradient means V by L, right? Yeah. So it is having resistance of how much? See, it is given that resistance per unit length is 0.5, but how much length of it is? 1 meter. That means it is of 1 meter. That means 0.5 ohms will be the resistance of this wire, right? So in this way, I have got the resistance wire to be one sorry 0.5 ohms. This is of 1 meter. Obviously, its resistance should be 0.5 ohms. Till here it is clear? Very good. Next, main thing is here only. Next, what I have to find? Current through this, right? Current through this wire. So what is the current passing through this wire? For that, 2V battery and internal resistance plus 0.5 ohms. You will get current to be how much? 2 by 2. It is 1 ampere. Wow, that's wow. Okay, next I have to find out potential gradient. That means across this wire. So the wire is of length L, and okay, K is equal to, what is the potential difference across the wire? Its resistance is 0.5 ohm, and its current through it is 1 ampere, and length of the wire is 1 meter. So the potential gradient comes to be 0.5 volt per meter. This is how we got the answer. How many of you understood this solution? This is important. I hope, Pritesh, your doubt is cleared about the potential gradient from this example. If every one of you understood this, please comment me you. Everyone, quickly, we have no time, we are having very less time. So please comment me, cooperate, so that we can proceed fast. Next example. This is just a basic example which is not involving, which is not at all involving potentiometer. Now we are going to do some potentiometer question. It is in this way. Given a length of the potentiometer wire is, hear me carefully. I'm not going to like the question. I'm giving you just data of the question. Length of the potentiometer wire is 1 meter. Okay, and its resistance of the potentiometer wire is 4 ohms. Okay, current flowing through it is, that is also given, that is 5 milliampere. Okay, an unknown source, hear me very carefully, this is the data of the potentiometer wire, and current through the wire also given to you. An unknown source, okay, unknown source of EMF E is balanced on 40 centimeter length of this wire. Okay, then find its EMF E. Very simple question, very simple. It requires half minute, not more than that. Let me do this question. See, I am given the length of the wire and its resistance, right? Battery is connected in this way. Okay, yeah, whatever it may be, but current passing through the wire is given to you. How much it is? 5 milliampere, right? Yeah. Now it is said that the EMF of the wire, let us say some external battery, external cell is connected across the wire and it is balancing, that means jockey is stopped here through the at the null point. Okay, so the potential difference of this 40 centimeter length, how much it will be? Listen me carefully. We know EMF E is equal to K into L1. Here the balancing length is 40 centimeter, it is given to you. Very good. It is given. So let us say it is zero point 0.4 meters in SI units if I take. Okay. And what about this potential gradient? So every one of you please comment me potential gradient, because in the last question we have done about potential gradient. So what you will get the potential gradient here? Very simple, very simple. So blog, everyone please comment me what is potential gradient here. What is the value of potential gradient? See, potential gradient means potential difference across the wire by the length of the wire. Here it is given that resistance of the wire is 4 ohms and the current passing through the is 5 into 10 power minus 3 amperes. So I R into I, this became the potential difference, and upon length, how much it is? 1 meter. So here I got potential gradient. It is to be 20 into 10 power minus 3 voltage per length per meter. Okay, so put this value here, 20 into 10 power minus 3 into its length is, how much is the length, balancing length? 0.4. So you'll get the answer to be how much? Okay, this is 8 into millivolt. So the battery is having the EMF of 8 millivolt. Okay, if anyone has doubt in this question, please comment me not. Rest remain silent. So I hope every one of you understood this question. Very important question. If you don't understand, please tell me here itself. Okay, or else it is going to trouble you in the exam. Okay, so if you are not able to admit here, okay, very good. This, I appreciate honesty. I like honesty. Please hear carefully. Please hear carefully. Okay, I know E is equal to KL1 is the formula for finding out the EMF of an unknown source. What is this K? K is the potential gradient through this wire. Which wire? This wire. Potential gradient, what does that mean? Potential gradient means potential drop per unit length. So if I say from point A to point B, what is the potential drop that we have discussed yesterday? It is how much? Simply V is equal to I into R, right? What is the resistance of this wire? It is given here 4 ohms. right? 4 ohms resistance, and current passing through the wire is 5 milliamperes. So totally it became 20 milli voltage. It is the 20 millivoltage is the potential drop across this wire AB. Till now it is clear. I have to find potential gradient, potential drop per unit length. How much is this length? 1 meter is the length. So drop, how much it is the drop? 20 millivolt is the drop. I am asked potential gradient. So 20 millivolt per 1 meter. So it became 20 millivolt per meter. Don't get confused, this is milli. Or else let us write it as 10, 20 into 10 power minus 3 volt per meter. Okay, so this is comfortable. Volt per unit length. Okay, yeah. So this is how we find out, we found potential gradient. Put this value here. That's simple. K 20 into 10 power minus 3 into length. L1 is the balancing length. It is given as 40 centimeter. We convert into SI units, it will come as 0.4 meter. Finally, you got the EMF to be 8 into 8 millivolt simply. Now, did you understand this, Snehal? Good, very good. Is there anyone who did not understand this question? I am going to give the same question, similar question with the changed values. If someone of you did not comment, I will take action on them. And I am asking every one of you to comment me answer privately. So no one is going to help you. So please be ready with your answer. Okay, because this is important, I'm going to fire you now if you don't say. If a potentiometer in a potentiometer experiment, when a battery of EMF 2 volt is included in the secondary circuit. I hope every one of you are familiar with secondary circuit, right? Huh. The balance point is 500 centimeter. Okay, find the find the balancing length of the same, and very important question of EMF 1.018. How much this is? 1.018 volt is connected to the secondary circuit. Okay, yeah, I'm going to make this VSA co-host, and I'm expecting the answer to be coming in the privately. Okay, yeah, make co-host. Okay, what happened to this? Okay, so VSA, please send me answers, your answers in co-host privately. Okay, stop your chatting and come to the work. Find out the value of this EMF, or what is asked here. Balancing length. Okay, yeah, please find out and tell me the answer. Come on, fast. Today is that birthday girl is there in this class. I'm going to dedicate. If she is there, I'm going to dedicate. No, she is not there. Leave it. I thought to sing an English song, which I have composed for my daughter-in-law, my sister's daughter. No, no, no. Okay, so no one of you has commented me till now. I'm going to find out the answer. Okay, time's up. Other Babang is the first one to send the answer. Okay, okay, 254. Aditi category, very good. You have answered me, but very good. In a potentiometer experiment, where a battery of EMF 2 volt is included in the secondary circuit, okay, the balance point is, so E1 is given as 2 volt and balancing length is given as 500 centimeter. I hope you are getting it. Huh? Find the balancing length of the same end from the same end when a cadmium cell of EMF, that means E2 is given as 1.018 volt. And what is asked here? Balancing length. What will be the new balancing length? That is L2 is asked. We know how to compare the cells. E1 by E2 is equal to L1 by L2. I have to find L2. So what I will do? E1 by, sorry, E2 by E1 into L1, right? So E2 1.018 by E1 2 into L1 is 500 centimeter. 500 centimeter can be written as 0.5 meter, or let it be 500 centimeter only, no problem. We'll find the answer in the centimeters, no problem. Okay, so you'll get this answer to be 254.6 F5, no problem. Okay, F5, okay, centimeter. This is how we find the new balancing length. If any one of you has doubt in this question, please comment me ND. Sorry, please comment me not. Okay. If any one of you has doubt in this question and solution, so please comment me not, or else we shall proceed further. Sir, but it has not given that the cadmium is connected in series or parallel. Yeah, some of you are having doubt in this way. Doubt is, see, question is, initially battery is there and resistance is there, the complete primary circuit is as it is. But the thing is, in the secondary circuit, first case we will connect a battery of EMF E1, okay, and we found out the balancing length to be L1. Now what I will do, I will remove this one and I will put another battery which is having EMF of E2. Now I'll find out the balancing length. Okay, this is L2 I'll get. Okay, and I'll compare. Here I have, if E1 is equal to KL1, E2 is equal to KL2. I'll take their ratio. I'll get E1 by E2 as L1 by L2. Got it? No need. That is meter bridge where the length of the wire should be completely 1 meter. Right? But here that is not necessary that the length of the wire should be 1 meter. Length of the wire I have told you here, right? It can be 5 to 10 meters also. That's why we connect sometimes the wire not in this way, we connect in this way wire. Like, Hena, yeah, here this is the point and this is the point, and from here we'll draw the batteries. Okay, because it will occupy more space, we will bend it in this way. Okay, we can bend in any way, but any 2 points of the wire should not come in contact. For example, if I bring them too close, then there will be again short circuiting, which is not desired. Okay. Oh no, I have already repeated once, so I have just now repeated for you. So initially E1 is connected and I found out the balancing length to be L1. Remove the first battery and connect to the second battery E2, and we found out the new balancing length as L2. Okay, if I take their ratio, I'll find out the new balancing length L2. That's it, very simple. And this is CET level question. Okay, yeah. Now Please do this question. In a potentiometer experiment, the balancing length with a cell is 560 centimeter. When an external resistance of 10 ohms is connected in parallel to cell, the balancing length changes by 60 meter. Find internal resistance. Very simple question. Please go through the concept which I have taught you yesterday, and then you will be able to do this question very easily. Okay. Yeah. So we basically how to find internal resistance. For that, what is the formula available? R is equal to L1 minus L2 by L2 into R, right? Yeah. If you remember the circuit, if you remember the circuit which we use here, this is in this way, right? This has to be memorized. And how you'll remember this? By means of practice. There is no other way. I hope you are getting it. And here is the balancing length. Okay. Initially, once switch will be open, है ना? And later switch will be removed. Okay. Yeah. So what is given here? In a potentiometer experiment, the balancing length with a cell is 50 centimeter. With a cell, that means with this cell, you found the resistance to be, I mean to say balancing length to be L1. Okay, L1. So let us write E is equal to K L1. Clear? When a when an external resistance of 10 ohms is connected in parallel to this cell, I have connected as external resistance in parallel to this cell, right? Yeah, of course, this is connected in parallel to this cell, right? Yeah. So this is of resistance 10 is equal to 10 ohms. Sorry, R is equal to 10 ohms. And now I found the balancing length changes by. That means L2 minus L1 is given to you. I hope you are getting. It is given that balancing length changes by. That means L2 minus L1 is given as 60 centimeter. L1 is given as 560 centimeter. And now what you are asked to find? Internal resistance. Okay, no problem. बहुत आसान, very easy. See, L1 is given, L2 minus L1 is given. So L2 will be how much? L2 will be, see, L2 minus 560. 9. Just a minute, small mistake is there here. In general, we know after closing the switch, what will happen? Balancing length reduces. Am I right? Am I right? Of course. Because if I close the switch, what will happen? Current will flow through this. Initially, potential difference between these 2 points, a very deep point. See, everyone should understand this. These 2 points, initially, if the switch is not closed, okay, if the switch is not closed, then circuit is only till here. And what is the potential difference through this EMF, through this battery? It will be simply E only. But once if I closed the switch, once the switch is closed, what will happen? Once the switch is closed, current has passed through this battery, and I will at that time I will get the potential difference to be E minus some IR, right? For the balancing length, no current is going, and current is to supplied by this battery current will be supplied by this battery, EMF E minus IR. So it is obvious that L1, right? L1 is greater than L2. L1 is greater than, should be greater than L2. If any one of you understood this question, understood this point, please comment me A. L1 should be greater than L2. If you understood, comment me A. Come on fast. My point of saying is that by closing the switch, current will pass and potential difference across the battery is reduced from E to E minus IR. So for less potential difference, I will get a lower value of the balancing length. That is the simple thing. Okay. So here, that's why I write L1 minus L2. Change is how much? L1 minus L2. And I have to find L2. How much it will be? 560 minus 60, which will be 500 centimeter. And now, I have to find out internal resistance, for which I have the formula R is equal to L2 L1 minus L2 by L2 into R. L1 minus L2 is given as 60, L2 is 500, and R value is how much? Is R value is given as 10 ohms. So total the value is 6 by 5 and 1.2 ohms is the internal resistance of this battery. If anyone has doubt in this question and solution, so please comment me not, or else I will proceed further to the next question. Comment me fast. Comment me fast. Okay, no one has commented me yet, so I shall proceed further. Yeah, a potentiometer wire is connected across the ideal battery. Now, the radius of wire is doubled without changing its length. The value of potential gradient options are increases 4 times, increases 2 times, does not change, becomes half. Come on fast. Comment me your answer. So you are given a potentiometer wire. Okay, it is connected across the ideal battery now. Okay, there is only primary circuit. Okay, good. Some people are answering me. Okay, very good. Lalit has answered me first. Next, Aishwarya Kunjis. Good. Your answers are correct. Yeah, yes, Aditi Katigare. Umka Sasure, you are wrong. Rishikesh, good, correct. Good. Let's see here. So what does the question say? Question says that there is a battery and a wire is connected across. This is wire is having some resistance. Okay, let us say this is the wire. Okay, this is the wire. Okay, yeah. Initially, okay, let us say the radius of the wire is r and length of the wire is l. Radius of cross section. Okay, radius of cross section and length of the wire is l. Okay, good. And this is having, let us say, e naught. Okay, and its resistance, let us say complete wire is having resistance of, complete wire is having resistance r. In that case, what will be the current passing through this? What will be current? Current will be e naught by r. R is the resistance. And if I say I have to find potential gradient for this wire, how much it will be? Potential gradient will be I into resistance, which is a potential drop across the wire, by length of the wire l. Okay, yeah. And here, if I say I into r by l. Okay, yeah. The radius of the, okay, we have derived some formula. Okay, then the radius of the wire is doubled without changing its length. Then the value of potential gradient, what will happen? Okay, this is the question. So first of all, does the resistance of wire change by increasing the radius? Obviously it changes, right? See me carefully. Hear me very carefully. Here I have, let us say, convert this to, okay. If I write here, k is equal to I. What can I write the I? I is equal to E naught by R into R by L. So k is equal to E naught by L. This is the potential gradient and this is equal to E naught by L. Here in the expression of potential gradient, I am unable to find the area. E naught is battery's EMF, which is constant. Length of the wire is not changing. So even if I double the radius, my potential gradient is not changing. The wire's potential gradient is not changing. So answer is does not change. If anyone has doubt in this question, please comment me not, or else I'll proceed further. Good. Most of you has commented me the answer. Okay. Good. If anyone has doubt, you can comment me either privately or publicly. Not. Okay. Let's proceed further. There are many more questions, but first of all, tell me, you people, whether you need more examples related to potentiometer, or is it enough? Is it enough? We have discussed around 4 to 5 examples on potentiometer concept, right? So are they sufficient, or shall I make you do more 2 3 examples? Comment me either privately or publicly in the comment box. Don't be mum. Okay. Okay, more 2 3. Okay, good. Just a minute. Some people are demanding for the higher level questions. Some people are asking, okay, more 2 to 4 questions. Okay, okay. So I will balance. Problem is the question is Questions are lengthy in here. So lengthy, a little bit too much time taking for me to write. So what to do? What to do? What to do? Mm. Okay, there is one good question. This is the last solid example of the CP Sync. If anyone have if you have this question, you can open. Okay, last solid example of CP Sync. Okay, I'm writing here. Okay, consider the potentiometer circuit. Okay, okay. Length of potentiometer wire 600 centimeter. Okay. Question is question A. At what distance from point A should be the jockey touches the wire to get zero deflection galvanometer? I will show you the diagram. Just don't worry. Okay, diagram is in this way. Okay, the diagram is in this way. This is having R, this is having EMF of E by 2, this is having EMF E, this is having resistance R, and the resistance of this wire is 15R. Okay, resistance of this wire is 15R. Okay, no doubt in this. Next, this is wire A, this is point A, this is point B. Okay, this is first part of the question. Length of the potentiometer wire is given to you. At what distance from point A should be the jockey if it touches the wire to get zero nil deflection in the galvanometer. Second part of the question is if the jockey, very simple one, okay, touches the wire at a distance of 560 centimeter from A, what will be, wonderful question, this is wonderful question, what will be current in the galvanometer? Wonderful question. Yeah, I hope most of you people will face difficulty in the second part. Okay, of course, I have to explain you the question also. No one will memorize the question. Other, right? Yeah. So this is the question. This is the wire length of the potentiometer wire is given. Okay. So we have to find out the both the answers. First part of the question can be easily solved. Not at all difficult. Okay. Second part requires your attention. So shall I do this question? Okay, let me proceed. Length of the potentiometer wire is given. Okay, okay, nothing to bother. At what distance from point A should be the jockey? Should be the jockey if balances the wire. Okay. So I know one thing. What? Simply E by 2 is equal to K into balancing length. Of course, I have to find the balancing length, right? Yeah. So L1 can be written as E by 2 1 by K. So I don't know even potential gradient. So let me find potential gradient for this. So let us say I'll find out the potential gradient here. Potential gradient can be found as delta V by length of the wire is, let us say, L. Okay. What is delta V? Current through it. And current V is how much? Let me do one thing. Hmm. Hmm. Okay, delta V. I have to find out that only, right? So this requires attention. I will write this in this way: E into 15 by 16. This is the delta V. I have written directly. This is just delta V I have written. Okay, this is just delta V. 15 by 16 E is the delta V across across the point A and B. How many of you understood this? 15 by 16 into E. What I have done? Simply I have done nothing. Very simple. This is a resistance. This is of resistance R. This is of resistance 15R. Yesterday I have explained you, right? This is E. This is 15. No, this is 15R. So I want potential difference across this. This is, let us say, V1. Let us say this is R1. This is R2. So what? How will I find out? V1 is equal to R1 by R1 plus R2 into battery, right? Simply I have put the same thing. 15 here, 15 plus 1, 16. And you'll get the value as 15 by 16E. How many of you understood this 15 by 16E by length L? Comment me A. Come on, fast, everyone. Without that, I can't proceed further. If you have doubt, please comment me. Please ask. I request you, but don't be mum. Okay. Sharyu Bankar, you are there in the class. Good. But yesterday you are absent. Can you know the reason? Okay. So I have found the 15 by 16 E by L. Right? Sanika Kale, have you understood how did I find this? 15 by 16 E by L. This is the potential gradient. Sanika Kale, please comment. Is she there in the class? Not there. Sanika Kale. Okay, there. Good. You understood. Good. So I have to place this in place of K. E by 2 and 1 by K, its value is 15 by 16. If I bring this upper top, okay, E 9 L E. So it will come how much? 8 by 15 L, where L is how much? 600. So 600, that means it will give me 320 centimeters. Someone has commented me this. Are who told that L should be 1 meter? I have never told. Aishwarya Kunjit, length of the potentiometer, length of the potentiometer wire is not necessary to be 1 meter. Is not necessary. It may be, it may be in the range 1 to 10 meters. Okay, it will be in the range of 1 to 10 meters. Okay, did you get it? Here L is given 1 meter, where here length of the potentiometer wire is given as 600 centimeter, right? So what's your doubt? Hope you got it. Okay, yeah. So this is how we found the first part of the question. Okay, if every one of you understood this, please comment to me go. If any one of you did not understand, comment to me not. Okay. Okay. If you understood, comment me go, or else comment me not. Got it? Yeah. Let's proceed to next question. Next part of the question. What does it say? It says if the jockey touches the wire at a distance of 560 centimeter. Okay, randomly, some point it is touched here. Let us say it is touched here. In this way, it is. Let us say it is touched in this way. How much distance it is? 560 centimeter. Very rapt attention is needed here. Okay, I hope so. Mm, you are asked to find out current, right? Mm, 11 by 8. No, please check your answer. Okay, your answer is not matching with the answer. Okay, okay. See me very carefully, very carefully. Mm, okay, this is anyway done. Leave it. Yeah. Galvanometer has no resistance because nowhere it is mentioned in the question. So you can take galvanometer has negligible resistance. Okay. Yeah. And the wire is touched here. Okay. And this length is given as 560 centimeter. Okay. Yeah. And what is asked here? You have to find the current passing through the galvanometer. It may be passing in this way or in the opposite way. We don't know it. So how will I find out it? Surely some current must be passing. Some current must be passing. Right? Obviously. Okay. Yeah. So we got 320 centimeter. Hmm. Okay. Okay. So please hear me very carefully. Initially at 320 centimeter, I have increased the level. Okay, this is having very good level. Initially for 320 centimeters, we got the current to be zero. And now if I increased the balancing length, I mean to say, if I increased the length, the potential difference across this branch is increased, right? The potential difference across these points A and B of the branch of this branch A and B got increased, right? Here at 320 centimeter, potential difference across this branch got balanced. But here this is having more potential difference. That means current will flow from this current from this side to like this. Did you get it? Yeah. So current will flow in this direction. Let us say some current passing I. Okay? Yeah. So now hear me carefully. Hmm, 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 hmm. So what I have to do now? Okay. I don't know. Let us say this is resistance having resistance R1. This is having resistance R1. This is having E. This is having R. This is having 15 R. This is already given 15 R. Good, very good. Okay. Complete wire is having 15 R resistance. And how much is this 560 having? How much will it be having? Leave it. And this is R1. This is R. Oh, this is R, right? Yeah, this is R, this is E by 2. Okay, this is E by 2. So just apply Kirchhoff's law, it is solved. Nothing more required. Got it? Just apply Kirchhoff's law, it is done. See what I will do. I will say current will be passing. I will be say current coming from here I. Okay, on this side I will be passing. This side I2 will be passing. So first of all, one equation I have got I is equal to I1 plus I2. Equation 1. Okay, next applying Kirchhoff's law in this loop. Okay, what will I get? What will I get? Some equation I will get. Kirchhoff's law, KVL. Okay, let us start from here. So what will happen? Minus IR, the current will be going in this direction. Yeah, minus IR plus E. Next, very carefully, minus I1 into R1. Okay, this is having resistance R1, and this is having some other resistance. Let us say this is R2. Okay, of course this is R1, this is will be R2. What is doubt in that? Okay, and we are going in this direction, current direction. So minus I into R2. Okay, R2 and the closed. Okay, we have achieved this point again. Okay, yeah, I repeat once again, I have started from here, current is flowing in this direction, so minus R, from negative to positive, so plus E, and we are passing in the, we are traveling in the current direction. These points, let us say this point to be M, this point to be A. AM is having the resistance of R1, and MB is having the resistance of R2. Okay, so R1 is having one current, R2 is having some different current. Okay, yeah, yeah. So here minus I1 into R1 and minus I into R2, and we reach this point again, back to this point, so 0. No problem, leave it. Okay, we'll get it. Okay, yeah, I'll get habituated slowly, slowly. Okay, nothing problem. Next, again apply Kirchhoff's law here. Ritesh, huh? So I'll start from point A. Let us say I'll start from the point A. So applying KVL, I'm passing from positive to negative, so minus E by 2. Okay. Before that, let me write proper equation from here. E is equal to what I will get, I R plus R2, right, plus I1 R1. Okay. This is one equation. This is one equation. Okay. And from here I will get I1 and R I2. So let me convert this into I1 plus I2. It will be very comfortable. Okay. So I1 plus I2 is put here. So R plus R2 plus I1 and R1. Okay. Yeah. Mm, okay. No problem. No problem. Or else leave it. We'll show other thing. I I only. Okay. We are changing nothing. Leave it. This is equation 2, let us say. Now apply KVL here. Applying from starting from the point A, we will get minus E by 2, and the current is flowing in this direction, and we are also going in that direction. So minus I2R, and galvanometer having no resistance, to ignore it, and again coming back to this point, plus I1R1 is equal to 0. Right, so here we got E by 2 is equal to I2 R minus I1 R1. In place of I2, put I minus I1. Okay, in place of I2, I can put I minus I1 into R minus I1 R1 E by 2. Okay, so now I have got an equation here. Please see very carefully. So I have got an equation IR minus I1 into R plus R1. Okay, and this is E by 2. What I have to find? I have to find I1, right? Oh, sorry, I have to find I2. Okay, no problem. It will be easily solved. So let me find first of all I1. Just a minute. Huh? Okay, no problem. See, this is equation 3. Solving 2 and 3, we will get some equation. See. What should I do? What should I do? What should I do? Okay, this I will write. There is nothing common here. Very good, very good. Good, good. R1, yeah, yeah, yeah. R1. See, R1, see, length of 600 centimeter is having a resistance of how much? Is having a resistance of 15R. If I say 560 centimeter, how much resistance will it be having? I have taken it as R1. And TK. R1 can be written as, now see properly, 15R 560 by 60. Right? Yeah. So here 15 40 times and 4, and this is, oh, okay, very simple now. So this is 40 plus 1 1 14 times. This is 14R. Oh, that is no simple, very simple. Good. And R2 value, if this is 14R, obviously R2 will be 1R because total is 15R. That's why. So I have got R2 and R1 also. Now it is very simple. So now see, put the values here once. IR minus R plus R1. This became completely how much? 16, yeah, 15R. Okay, 15 I1 R E by 2. Here also I into R2 is R, so it is 2R plus I1 into 15 9, this is 14R. Okay, this is 14R. Yeah, now it is simple. Okay, let me remove this. Okay, now see what you have to do here. Hmm. Okay, let us solve. Somehow we can solve this. E minus I E minus 2IR by 14 R will give me I1. Let me put it here. E by 2 IR minus 15 R into I1 is substituted with E minus 2IR by 14 R. So here R cancel and IR minus 15 by 14 E minus 2IR, and this is E by 2. By solving like this, you will get the I value. How much you will get? I value. Will someone do? Okay, let me do. Hmm. What will I do now? Okay, I will bring this out like this side. So it will come E by 2 plus 15 by 14 E. And this is I. If I take common IR, next I will get 1 plus 15 by 7. Okay. Galvanometer is not considered having resistance because it is having negligible resistance. Okay. Yeah, that is why. Got it? Okay. Arey. Next. So solving this way, you will get I. I how much? Okay, let me do here only. Here 14. Here 7 E plus 15 E. 22 E. Hmm? Hmm. Is equal to R is brought down, and here 7 plus 15 22 by 7 I into R. So 22 cancels 7 2 times. Okay, R is taken that side. So I have finally got I is equal to E by 2R. Oh, oh. Finally I got I value. So, so putting this I value here, where in this, what you I1 you will get as E minus 2 into R I. Okay, in place of I, put this one. Okay, now 14 R. Okay, is equal to I1. Now 2R to, what happened? Just a minute. Just a minute to. Hmm. Two are getting cancelled. This is not possible. I1 is equal to 2R. No, no, Harshal. No, not at all. It would be difficult for me. Just a minute. Somewhere we have done some mistake. Okay. In a brief, I will tell you. Okay. Just this is calculation only. See, we are having two equations. KVL equation. This is one. This is two, and this is three. Okay. Solving one, two, and three, you will get I. You will get I1. You will get I2, and we have to find I2. Okay, that is the same thing. That is the only thing we have to find. Got it? Every one of you? Okay, somewhere some mistake is done. I'm unable to get it. Okay, but I don't want to waste time in front of you. Leave it. Okay, you are having three proper equations with you. This is one equation, this is second equation, this is first equation, third equation, second equation, right? By solving three equations, you will get you'll be able to solve the three unknowns, right? That is the thing we have to find. Answer, you will get I2 to be, you have to get 3 by 3 E by 22 R. But here I am getting I0. That is where I am stuck. Okay, even if I put I0, I1 I am getting 0, then it will be I E by 2R, which is not acceptable. E minus 2R by 14R. Okay. Mm, E minus 2IR is equal to 114R. Which I have taken out correct. Mm, okay. And that is what I am telling. This is wrong. Till here it is wrong. Okay. Got it? That is not possible. There will be some other calculation. I will show you tomorrow. Okay, nothing to worry. That is not waste time here. Okay, process is the same. There is no doubt in it, which you know. And for the case of solving the circuits using Kirchhoff's law, that all you know. But still, the thing is somewhere we have done some calculation mistake, because of which we are driven in this way, wrong way. Okay. So let us sort out it tomorrow. Nothing to worry. Let's come to the new topic. Okay, without wasting time. And which is very important, of course. That is important. That's why we are discussing the class. Okay. Yeah. The question is, the new topic is electrical power. Electric power. You are familiar with the word power, right? Rate of work done, yeah, rate of energy supplied. Rate means time rate, right? How much energy is supplied within this much time? That quantity that can be measured. Yeah, you can say like that. Lalit, yes, started a new chapter according to Singh CP Singh. Okay, but of course it is a whole one chapter only. Electrical power, okay, it is not, it is just a small concept. There are so many other things which are not at all there for your JEE or NEET. Okay, yeah, this is what heating effect, electric power. Okay. Ha. Let us discuss on this now. Heating effect is that this only. Okay. Hmm. Okay. So let us discuss how heat is released when we pass current through the conductor. I repeat, let us discuss how heat will be released when current is passed through the conductor. How this question is coming in everyone's brain, right? Yeah. So we know one thing. Let us say there is some conductor. Okay, this is having potential VA at this end and VB at the other end, right? And let us say I am saying uh, some current is passed through this conductor and it is I. Of course, current will pass only when there is some potential difference across this, because it is having also some resistance, and there should be definitely. Okay, no problem, Abhishek. Okay, I and current will be passing through this conductor, right? Yeah. And now we know that current is nothing but rate of flow of charge. That means if I say delta Q, how much charge is flown within delta T time, how much charge will flow? I into delta T. This much charge will flow within delta T time through this conductor. Okay, let us say. Okay, yeah. And the charge delta Q is moved from here to, from this point to this point. That means it will lose some energy, it will lose some potential energy. I know we have even discussed in board class also. If a charge delta Q, if a charge, let us say Q only, okay, not delta Q. If I say charge Q is placed at a point with potential Va, then its potential energy will be given as, how much potential at that point into the charge. This is the potential energy possessed by the charge at this position. Position, see, hear me very carefully. Potential is the energy possessed by virtue of its position. Energy possessed by virtue of its position. Yeah, as soon as the charge is brought here, it will gain some energy. That is how much? This much energy. By virtue of its position, it has gained this much energy, which is called as potential energy, and this is Va into Q, where Va is potential at that point. Similarly, if it is reached here, then its energy will change, and its energy will be UB is equal to VB into Q. Similarly, right? And tell me one thing, if current is flowing from point A to point B, then which is higher potential, Va or Vb? Not electrolytic. Let us discuss that thing. Harshal, please wait. Okay, that is not electrolytic. I agree with your point that is because of collisions. Okay, what? You agree? Okay, good. So Va is higher potential. Va is at a higher potential. Obviously, current flows from higher potential to lower potential. That means if I consider this charge, this is losing some energy when it moved to point B, right? It is losing some energy. It is losing some energy, UB minus UA, which is less than 0. And how much is that energy that is lost? Delta V into Q. This much energy, of course, this is the change, right? This is the change, and that is lost. That means potential energy is decreased. Then in general we know that kinetic energy of this charge should rise. We know this thing. When we drop a body, freely falling body, initially it has good potential energy and zero kinetic energy. But once it reached here, its potential energy zero and kinetic energy is higher. That means change in potential energy is taken as change in kinetic energy. Loss in potential energy is gain in kinetic energy, right? Obviously, the same way we generally expect this thing that potential energy got decreased and so the kinetic energy of this charge should get increased, but that will not happen. Why that will not happen? Because we know that current carrying charge, I mean to say charge carrying particles, okay, let us say they are charged particles, okay, and to be in brief they are charged particles, okay. Hello, students. Are you able to hear me? Okay, so what has happened? I'll just briefly tell you. What happened is Deepak sir thought that we are wasting a lot of current, so he went to the switchboard and he switched off all the switches. But in that switch, one switch belongs to this router. Because the router got off, so we lost the internet here. Arey, right, I'm saying I'm right. I told you right thing. Okay, if you want to ask, call to Deepak sir what he has done. Ask him. Okay, he will tell you. Okay, see here. We were discussing. You want attendance? I will take attendance. Don't worry. I will take. I have. I know. I remember that I have to take attendance. Okay. Uh, So please hear me very carefully. I was discussing that we know that a charged particle's speed is constant, which is called as a drift speed, and that remains constant, steady. Okay, that is not changing. So if the kinetic energy is not increasing, see, if the speed is constant, that means delta Ke is zero, right? There is no change in the kinetic energy, but at one side you are seeing that potential energy got decreased and there is no increase in the kinetic energy. Then what is the where is the energy going? Yeah, so energy is going, is lost while the collisions. Yeah, of course, please make me host. Are you able to see the screen? Okay, are you able to this? Okay, good. What happened, Harshal? You raised your hand. Abhishek, make me host. I'm not able to. Yeah, that is private chat. I am able to see. What review? Which review you want? Huh? I know camera is not on. Yeah, thank you, Abhishek. Oh, Abhishek Jakate was caught sleeping. Really? No, no, he was there. He was seeing in YouTube. He told me before only. Okay, don't worry. Yeah, so come here. Let us discuss here. So the thing is, we know that in a conductor, electrons collide with the atoms, ions, right? During this collision, what are the charge particles? Charge particles are the electrons. Charge particles are supposed to increase their kinetic energy. But what will happen? No, they are not doing that. That means the energy that is supposed to increase the, that is lost here, okay, that is lost here is shared with the ions or cations. Okay, yeah, yeah. So that is lost with this ion, that is shared with this ion. What will happen that time? Yeah, when the energy is taken by this ion, it starts to vibrate vigorously. And you know, when temperature, because of vibration of these atoms, vibrational of course, because of accepting energy from this charge particle, right, the vibration of the ions or atoms got increased. Okay, vibration got increased, and because of vibration we come to know that the thermal energy is released. Got it? This is how energy is lost across a conductor when current passes through it. No, no, there is no concept of wire friction. Okay, that is just a word which will make you understand that there will some dissipation of energy. But exactly, this is the funda. This is the main reason. Okay, and this is given in NCRT. Okay, if you want, you can check there also. Elsewhere, nowhere else you will find this. Okay, not even HC Verma you will find this concept. You may be finding. Okay. Uh, I'll just make you. I will give you notes and I'll explain you. Okay. I will give you notes and then I'll explain you once again. Don't worry. Consider a conductor AB. Very interesting concept this is. Through which current I flows from A to B. Are please wait. Just hold on for this class. Okay. Just for this class. Ritesh. PD across AB is delta V, which is VA minus VB, which is greater than 0. Conductor is in this way. Okay, this is A, this is B, VA, VB. Current is passing in this way, I. Okay, and in a time interval, delta T, how much charge will flow? I into delta T flows from A to B. Flows from A to B. Okay, yeah. That means change in potential energy will be how much? Change in potential energy can be written as delta U, and it is how much? Delta Q into to charge. Let us say Q charge will flow. Okay, yeah. So Q into delta V, right? Q into delta V, where this can be written as VB minus VA, and which will be less than 0, right? Yeah, till now you have written. Next, now hear me very carefully. If these are my words, okay, they are not copied from NCRT. If potential energy of charge decreases, then their kinetic energy would be expected to increase. However, we have seen that charge carriers move with a steady drift speed, or say let us say lift velocity. Okay, this is because of the collisions with ions and atoms during the transit. What is meant by transit? Transit means charge is moving from one point to another point. During that motion, it will have so many collisions with ions and atoms. Okay, and there it will lose some energy. Okay, yeah, during the transit. Okay, energy gained by the charges is shared. We expect that kinetic energy should be increased because it has gained some energy because of electric field. Electric field, will be from higher potential to lower potential, right? Obviously, that means higher potential to lower potential, charge also flows. It is pushed by the electric field. So because of force it will gain some energy. Acceleration is expected, but it is not there because of collisions. Energy gained by the charges is shared with atoms during collisions which vibrate them vigorously, more vigorously. That is, conductor heats up. Thus, in an actual conductor, the amount of energy dissipated as heat in the conductor during time interval delta t is given by how much is the lost energy? Lost energy is delta v into q, which can be also written as delta v into I delta t, right? So this is the energy that is lost. Okay, delta v can be written as v potential difference, let us say v. Okay, v I into delta t. And if I write energy lost per unit time, okay, this is v I, and this we say energy dissipated. Hmm, just a minute. Energy dissipated, okay, and this is energy dissipated per unit time. This is what? This is power. This is power. I know v is equal to IR. If this is a conductor, across that conductor potential difference is v, and the resistance of that conductor is v, then in place of v I can also put IR, and I'll get I square R, right? Or else in another way, in place of I can put v by r, and I will get v square by r. So basically we are having three forms for a power dissipated formula, which is vi I square r or v square by r. Okay, you can apply, you can use any of them, depends on the question also. Got it? Yeah. Okay. Okay, nothing to worry. It is this power which heats up the coil of an electric bulb to incandescence, radiating out heat and light. It is the chemical energy of the cell which supplies this power for as long as it can. Mm, leave it. Okay, yes. We know that battery will supply some energy, right? If you use a battery for a long time, it will get drained out. Just few minutes, just 5 minutes. Okay. It is the chemical energy of the cell which supplies this power. That means battery is having some chemical energy that is supplied to the any electrical resistance. Let us say it is bulb or something else. Okay. Yeah. So let us do how questions will come on this thing. Okay. See, if I say there is a battery which is having of EMF of 20 volt, and if I say there is a resistance which is having 10 ohms, okay, find the first question is find the power dissipated across the resistance in the resistance. Incandescence bulb है. This is bulb. Okay, bulb. Okay. Hmm. Second question is how much energy is released in 2 minutes? Okay. How much energy is released by the resistance in 2 minutes? So please quickly answer me. Okay. Uh, okay, Pritesh, don't worry. Okay. I have seen your answer. So everyone, please comment me your answers. Good. See, very simple. We are asked power dissipated, right? What is the power formula? I square R या नहीं तो B square by R. What is the potential difference across this bat resistance? 20 volt. So V square is 400 by R 10. This is 40 units of power are watt. I forgot to say you. Of course, basically you know that, na? Hmm. You can write this here. Units of power. Joule per second or watt. Okay, and kilowatt watt. ठीक है, किलो watt, right? Yeah, yeah. Okay, and one more question to you. Energy is no, nothing like that. Even before coming to the class, I don't know that I'm going to speak. I'm going to speak in English, but at that moment, my mind told me. Okay, my mind told me. Take today's lecture in English. Okay, yeah. So find the resistance. Okay, find the energy released in 20 in 2 minutes. So this is first part of the question. This is second part of the question. Second part of the solution. See carefully. How much energy is released in 2 minutes? We know power is equal to E by T, energy per unit time. If I am asked E, so what I will do simply P into T. What is the power? 40 time how much? 2 minutes, right? If I convert it into 6 seconds, it will be uh, 120 seconds, right? And I will get the answer to be 4800 joules or 4.8 kilojoules, right? Don't. Okay, don't do like that. Okay. I know that I am not. Actually, I have lost habit of speaking. In my school time, I used to speak. There is punishment also. If someone speaks in Telugu, they should pay around 5 rupees fine. It was the fine in my school time. But afterwards, there is no such rule. Sometimes it comes, sometimes it will not come, right? Yeah. Okay. So find the power dissipated across this 3 ohm resistance. Never listen to your mind without think. Oh, mind is a friend to you if you properly use it. Mind is the enemy to you if you don't control it. Obviously, those who heard that point never listen to your mind. That is wrong. That is never said in mind. And it is gone. Okay. Yeah, our constitution has given proper vision to speak in any language. Of course, if you want to speak, if you want to ask doubt in Marathi, you can ask doubt. No problem. But the doubt will be remaining as a doubt only. It can't be solved. Okay. Yeah. So please, we're having very less time. Of course. So I'm going to solve this question. I have to find the power dissipated. Find power dissipated in 3 ohm resistance. Right? Okay. See here carefully. See, most of you people are unable to find out the current passing through this. So I request everyone if you first of all tell me what is the current passing through this branch. What is the current passing through this branch? Okay, what is the current passing through this branch? Every one of you will comment me these currents in privately. I want to see once here. Okay, okay, yeah. Even though they may be similar. Okay, even though I understood. Okay, but I will not solve. It's not like that. I will solve. Yeah, please comment me first of all what is the current in this branch I1. Everyone, please comment me what is the current passing through this branch. I am asking about I1. Okay, I1. See, it is very simple, very simple. See, this branch is having how much resistance? This branch is having 8 ohm resistance, right? Yeah, and this branch is having 4 ohm resistance, right? Yeah, and I know if current I is coming from here, or else leave it, no problem. If I say current, how much across this branch, it is 30 volts is the potential difference across this branch, right? So I2, how much it will be? I2 will be simply potential difference across this resistor 30 by resistance. So it will be 7.5 ampere is the current passing through 4 ohms. Right? Next. Okay? Next. So what I have to do next? Similarly, I have to find I1. But I don't know. So, no, you cannot say like that. I1, if I say, what is this branch resistance? It is 8. And what is the potential difference across this branch? See, this is the branch, right? And potential difference is same again 30. And here you will get the value as how much? 15 by 4. 15 by 4 can be written as 3.75 a ampere, right? I hope it is correct. Huh? Okay. Is it correct or wrong? Huh. Current passing through this branch is found out in one step. Are you imagining? Just imagine current passing through this branch can be found been one step, but you have to practice. For putting this step, this is very simple step, but for understanding, okay, you have to do good amount of practice. You are not practicing sufficiently. Really, I'm very upset with this. Leave it. Next, current passing through this branch is found out. And what is the power dissipated across this resistance, along that resistance? So I know current passing I square into R, right? I value is found out 3.75 square into 3. You'll get the value how much? Can someone comment me this answer? Please comment me someone this answer. 3.75 into square. 225 by 16 into 3. 42.18. This is a watt. How many of you understood this question or this solution? Please comment me go. So I will end the class here. Every one of you. Before asking for the OBT, first of all tell me whether you solved the previous OBTs or not. Okay.